All right, hello everybody. Today we are going to be doing notes on section 1.3 and 1.6, solving linear equations and inequalities. This abbreviation here, this is how I abbreviate the word equations. I will use that throughout the entire year. Go ahead and take a minute to pause this video to write down your title at the top of the paper and the first example. All right, let's go ahead and get started. So when we are solving linear equations, our goal is to get the variable by itself. In this one, our variable is y. So I can either subtract 9y from both sides to get all of the y's over here, or I can subtract 7y from both sides to get all of the y's on the right. It does not matter whichever one you do, your personal preference. For myself, I like to keep the variable positive whenever possible. So I'm going to subtract 7y from both sides. Cancel out on the left side. Now I'm left with 13 equals 2y minus 5. Now I want to isolate the y. To do that, I must first add 5 to both sides. 13 plus 5 gives me 18 equals 2y. Divide both sides by 2, and I end up with 9 equals y, which I can rewrite as y equals 9 with the variable first. All right, let's look at another example. Scoot this down a little bit. All right, next example. I want to solve 3 times 5x minus 8, close the parentheses, equals negative 2 times negative x plus 7, close the parentheses, minus 12x. All right, now for this one, I have more than one option of where I can start. I'm going to choose to distribute on the left side and the right side of my equal sign, just to get it all knocked out in one step. So I'm going to distribute that 3, and I'm also going to distribute the negative 2. So I end up with 15x minus 3 times 8 is 24 equals, negative times a negative becomes a positive, so 2x, negative times a positive becomes a negative, minus 14 minus 12x. Now I'm going to do something called cleaning up, or in other words, combining like terms. On the right side, I have a 2x and a negative 12x. I'm going to go ahead and combine those together. Left side stays the same. This is now equal to negative 10x minus 14. Now I want to get all of my x's on the same side together. Again, I like to keep my variable positive whenever possible. So I'm going to choose to add 10x to both sides. Cancel out over here. I'm left with 25x minus 24 equals negative 14. Add 24 to both sides. And I get 25x equals 10. Last step, divide both sides by 25. And I get x equals 10 over 25. But that can be simplified. Those have something in common. It can be reduced. 5 goes into both of those numbers. So I can write this as x equals, 5 goes into the top twice, 5 goes into the bottom 5 times. So I can write this as 2 over 5, or if you prefer to write it as a decimal, you can write it as 0.4. All right, let's transition over to inequalities now. We're going to start with basic inequalities. We are going to solve and graph. Solve and graph 5x plus 2 is greater than 7x minus 4. All right, now we're going to solve these exactly like we did the equations, except now we have an inequality instead of that equal sign, but still the same idea. So I want to keep or get all of my x values together, and writing this in proper form is with your variable first. So I'm going to move all of my variables over to the left-hand side. So I'm going to subtract 7x from both sides. Now I end up with negative 2x plus 2 is greater than negative 4. Subtract 2 from both sides. Now I have negative 2x is greater than negative 6. Now this last step, dividing by negative 2. Negative 6 divided by negative 2 is positive 3. But when you multiply or divide by a negative, what do you have to do to your sign? It flips. So flip the sign. When you multiply or divide by a negative number. So my final answer is x is less than 3. All right, now I want to graph this. So I'm just going to draw a quick little number line. Draw it over here. Now I'm not real picky about the number lines. You don't need to put tons of numbers on this. I'm going to put the number I'm actually using, which is 3. And I'm going to put one number to the left and one number to the right. Now, just a reminder, use a different color pen for this. For your inequalities, for graphing, when it is greater than or less than, it's an open circle. What that means is that that number is not included as part of your solution. When it's greater than or equal to or less than or equal to, it's going to be a closed circle. So are you going to have an open circle or a closed circle for this graph? Good, it will be open. All right, now you have the option. You can either draw it directly on your number line. And when I do this, I like to either use a different color pen or a highlighter or make a little squiggly line to say it's everything less than 3. Or if you prefer to draw your graph above your number line instead, just as long as it's obvious and easy to see where your graph is going, what direction it's going, either to the right or to the left. Just make sure it's easy to tell. All right, let's go ahead and transition now. We are going to now get into compound inequalities. And I'm going through this pretty quick and only doing one example of each because this is all review of things you have learned before, both in elementary school and algebra, and you probably reviewed it a tiny bit in geometry as well. Oops. All right, so let's write down my next example. So we're going to do the compound inequality that is an and inequality. So solve and graph with -4 less than 6x minus 10 less than or equal to 14. All right, so for this problem, my x value is only in the center. I need to get everything away from it. So same rule of moving things away from it. I'm going to move the 10 first. And the thing you need to do here is make sure you keep it balanced. So if I add 10 in the middle, I need to also add 10 to the left side and add 10 to the right side. You need to keep this balanced. Imagine you have 3 scales. You need to do the same thing to each of them. The 10s in the middle cancel out. -4 plus 10 is 6. 6x is left in the middle. 14 plus 10 is 24. Let's see, that a little easier to see the pencil. Yeah, a little bit. I'll turn the light on. All right, now my last step I need to do is divide by 6. And again, if I divide the middle by 6, I also have to divide the left side and the right side. It needs to stay balanced. So this becomes 1. I'm left with the x in the middle. And 24 divided by 6 is 4. My x is now isolated, so I'm finished. Now the way we read this is x is between 1 and 4. That's what that means when we look at it. And when we graph this, we're going to have 2 circles instead of 1. This one is going to be open. This one is going to be closed. So when I draw my number line, I'm going to draw it over here. Again, I'm not super picky. You don't need to label your number line with tons and tons of numbers. So my small number is 1. My big number is 4. If you wanted, you could put the numbers in the middle. You could put 0 or 5. All right. Now for the 1, that is an open circle. I'm going to show the other way of graphing this. So I'm going to graph it above the number line. So it's an open circle at 1. 4 is a closed circle. And it's everything between those numbers. So everything between those numbers is that space there. So whatever your preference is, if you want to do your graph like my last example where I put it directly on the number line, if you want to do it like this example where I place it a little bit above, just as long as it's easy for me to tell where you are graphing. All right, we're going to do one last example. This one is also a compound inequality. This is one of the OR statements. So we are going to solve and graph 3x minus 1 is less than -1, or 2x plus 5 is greater than or equal to 11. All right, so I'm going to be solving both of these equations to get 2 separate answers. All right, so let's look at just this one over here on the left. First thing I'm going to do, add 1 to both sides. 3x is less than 0. And then we'll divide both sides by 3. What is 0 divided by any number? 0 divided by anything is 0. So that's half of our answer. Now I need to solve the other one. So I'm going to subtract 5 from both sides. 2x is greater than or equal to 11 minus 5 is 6. And then we'll divide both sides by 2. So x is greater than or equal to 3. And remember, this is the OR statement. All right, and then for graphing this one will be open because it's less than, which means that number is not included. This one will be closed because it's greater than or equal to, which means that number is included as part of your solution. Oops, sorry. All right, so let's go ahead and draw the number line. All right, so my numbers are 0 and 3. Again, you can just draw those, or if you wanted, you can do the 4 and the -1. Please don't make your number lines go out super, super far. Like, don't go all the way from -10 to 10. That's just really tedious and way more writing than you need to do. All right, I'm going to show the example again with the other method of graphing this, putting it directly on the number line. So I'm going to have an open circle at 0. And it's less than. So all of the numbers less than 0, which is going to the left. You may also notice that's the direction that this is pointing. It looks like an arrow. You go to the left. Then at +3, it's going to be a closed circle. And it's everything greater than 3, bigger than 3. Everything bigger than 3 is this direction. Which also, if you notice, as long as your variable is written first, your little inequality symbols go the same way. Your little arrows point the same way that they're written. The only time that that does not work, that rule, is when it's written directly like this, because this is like saying x is greater than 1 and x is less than or equal to 4. If you were to write this out as 2 separate statements, your arrows would point towards the middle, towards each other. All right, so that is the end of our notes. Again, this was all review on just solving equations and solving inequalities. You can go ahead and stop the video now.